It's myself Purvi Sankhe. I'll be taking session on continuous integration in DevOps. Earlier we have taken session on version control in DevOps. Now we'll continue with the next phase of DevOps life cycle, that is continuous integration. See the definition and importance of continuous integration in DevOps. So continuous integration is a DevOps practice where developers frequently merge code changes into a shared repository, which then triggers the automated builds and the tests. Okay, this ensures early detection of integration issues. When we say integration issues, so what kind of integration issues are there when we are trying to integrate the code base or code changes? So we'll see the integration issues first. Integration issues can be like a merge conflicts when multiple developers modify the same code or the file, which Git or other version control systems may not be able to automatically resolve the differences in. Okay, for example, we have two developers A and B working on the same file. A renames the method from the file named as login service.java to from validate users to authenticate users, and B adds a new logic to the validate user method. Okay, so when both push their changes, the CI pipeline detects the conflict in both the methods to this file login service.java, and immediately it prompts those changes and resolve it before the build continues. Okay. So this is how CI help in the integration issue of merge conflict. Okay. Then the other issue might be broken builds where newly pushed changes may not compile or pass the build scripts. For example, if developer D forgets to import a required module or uses a method that doesn't exist anymore, so that time what happens, how this issue can be solved by the continuous integration. So CI builds the step fill with compile error mentioning that cannot find a symbol. So the team is notified immediately and the problem can be resolved over here immediately. Other issue can be dependency conflict where code formatting or naming conventions are not followed. Okay. So for example, developer E commits a Python code without following this peptide standard. So that time what happens, CI tool like Fleck 8 or Pylint throws error. Error can state like this: E302 expected, two blank lines and found one. So CI fails the build until the formatting has been fixed. Okay. The other issue can be code style violation or linting errors, where the one developer may update or add a new library or package that breaks a compatibility for others. Example, developer C updates a library version in form.xml from the Spring Boot version 2.5.0 to 2.7.0, which introduces breaking changes. So CI runs the build and throws that errors due to API deprecation or change annotations, ensuring the problem has been caught before the deployment. Okay, so we can see how CI helped in this issue also. The other issue can be configuration mismatch, where the differences in development and test environment setup can cause unexpected errors. So an example is an app is working locally but CI pipeline fails because database URL environment variable is not set in the CI environment. So it will show error stating database URL not found. So this prompt proper environment setup for consistent deployment, and the issue of configuration mismatch will also be solved by the continuous integration. Okay. So we have seen these different issues which can be easily solved by the continuous integration in DevOps. Okay. So how does continuous integration works? We can see in this diagram continuous integration in DevOps. So we have a developers, we have version control server, and we have build and automated test. So what happens over here? Developer writes the code and pushes it to the shared repository, whichever tool we are using. For example, here we have mentioned it as a GitHub. Okay. So the version control system stores the code, whatever code has been pushed. CI server like Jenkins or GitLab CI that checks for that pushed new code, and then it builds the code automatically, and then it runs the automated test to check for the errors. This is how continuous integration works in DevOps. Okay, this was the flow shown to you. If everything works properly, it sends a notification like an email to the team that the test has been done and the code is error free or bug free. Okay. How How does continuous integration works over here? With continuous integration, developers frequently commit to a shared repository using the VCS systems, using any of the tool, Git, GitHub or GitLab, etc. Okay. Prior to each commit, developers may choose to run local unit tests on their code as an extra verification layer before integration. A continuous integration service automatically builds and runs the unit test on the new code changes to immediately surface if any errors are. How does continuous integration works? Continuous integration refers to the build and the unit testing stages we have seen in previous slide of the software release process. Every revision that is committed triggers an automated build and test. With continuous delivery, code changes are automatically built, tested and prepared for a release to the production. And then continuous delivery expands upon continuous integration by deploying all the code changes to a testing environment or a production environment after the build stage. We'll see the CI workflow. CI workflow starts from developer commits a code. So each time a developer writes a new code or modifies existing code, they commit it to the shared version control system. For example, Git. We have taken it as Git. For example, a front-end developer commits a new login page component to a GitHub repository. The second step is automated build and test is triggered. So a CI tool, any of the CI tool detects the commit and automatically runs a build and then goes for the proceeds with the automated test. Example, Jenkins triggers the build and runs unit testing for the login feature. If login breaks existing functionality, test will fail and same will be notified. Then the next is feedback sent. The CI tool sends instant feedback to the developer. Feedback may include the statement like build success or build failure, test results will be mentioned, or code quality issues, if any are there, can be mentioned in the feedback. Okay. Example is given how feedback can be sent. Suppose a Slack notification or email alerts will be sent to the developer, which will state build hash 124 failed and 2 unit tests were performed and those are filled in the page named as a login.js. Okay. So benefits of continuous integration can be early bug detection because bugs are caught before they reach the production or staging process and developers know immediately when something breaks. Other benefit can be faster feedback. Developers receive test or build results quickly. So it encourages regular or small commits and quick improvements. Better code quality since the frequent builds and tests ensure stable and reliable code. It encourages coding disciplines and documentation. So ultimately it produces a better quality code. One example, a real life example of CI pipeline is Zomato. A team at Zomato develops a food delivery web application where the developer commits a new cart logic to GitHub. GitHub action runs a pipeline, builds the app, runs Cypress end-to-end test, then test fails due to a broken button click. Developer gets a Slack notification and fixes the bug. After recommit, tests pass and the code is ready for the deployment. Okay. So this is about the continuation integration in DevOps. Thanks friends.